where the inference is done, the raw inference is done. So you'd have a YOLO model running on your edge or something like that. You do the inference, and then you take action based on that inference. Vik Mehta. I'm a founder of Upplink, UPPLINK. We're a startup. We're based out here in Richardson, and we're working on hardware for.
Fantastic.
Yeah.
All right. Do you want this to be interactive, or do you
Yes,
want to hold
yeah,
it?
please.
Okay. All right. So if you have
Yeah.
questions, let them know.
Let's go.
All right.
Good seeing you. Good seeing you thermally. Also,
Why are my chins looking different?
yeah. There you go. That's just have a drink and everything will be all right. All right, let's go.
That's better. You can cover my chins, that chin guard.
All right. So basically,
You didn't know how to shop, right?
from this session, do these guys look familiar? That is Chris right there, and that is Ed from their LinkedIn profiles. I said, take these guys, make them gourmet chefs, and put them in a commercial kitchen. So, there you go. So basically for tonight, yeah.
Don't show that to my wife. She'll expect that. Then I'm in trouble.
Okay, you'll see the next thing.
If it were for a microwave, I'd starve.
Yeah. So with IoT, we want to detect something like this, and with IoT, we want to prevent something like this. So, are there ways to make sure that the gourmet chefs don't go all crazy? Hence the thermal camera. We talked about a little bit about two types of IoT protocols out there. They're called LoraWAN and Wi-Fi HaLow. LoraWAN, it's been around for quite some time. Very popular, long-range wide area network. And Wi-Fi HaLow, even though it was codified a few years ago, it's just now coming online. And they're kind of complementary. It just makes for, I think, new applications, hardware, etc., for IoT in the next coming years. And some of the similarities are, yes, they fall under a low power wide area network designation. And they use some 1 gigahertz unlicensed band. Here in the US, it's 900 to 928, and then other parts of the world, Europe is in the 800s, and different spectrums in different parts of the world. Both are mostly used for IoT, and based on, like, for instance, LoraWAN, small payloads, and so allows for a highly scalable gateways. So highly scalable deployments. Basically, you put one gateway out there, and you can handle hundreds, possibly even 1,000 plus endpoints. And both of them are their devices are efficient, and some of them can last for years. You can put them in temperature sensors, etc. Deploy them in your environment, and forget about them for like a couple of years. And so here are some of the differences. LoraWAN is more towards long range, and definitely has a higher long range than Wi-Fi HaLow. And that's done by they have a way in which they modulate how their chirp is. They have a way to hop over the spectrum and then get through a lot of noise. And but that is with high latency and small payloads. And that's why Wi-Fi HaLow is complementary to LoraWAN, because you can select your channel and you can basically stick with that one channel. It's a more traditional way of it falls with the other Wi-Fi protocols. LoraWAN insane range, 3 kilometers in urban areas, and Wi-Fi HaLow is essentially a tweak of 2.4 gigahertz. So it's about sub 1 kilometer range, but it's pretty good. I mean, it'll cover a large building or a campus or something like that. LoraWAN definitely, when it comes to provisioning, it requires its own gateway. So it has a LoraWAN network server is one of them, and so all packets go to that gateway, and then from there it gets sent to your application. And so it's not IP based, and then also communication. Whenever a endpoint, a LoRaWAN endpoint, talks to the server, that's the only opportunity where you can then reply back. So it sends back information. So that's kind of the way in which the LoRaWAN tries to be much more efficient than Wi-Fi HaLow. Wi-Fi HaLow is IP based, similar to your Wi-Fi, the other Wi-Fi protocols. And the data rates are capped or they're just because of certain requirements. For instance, there's a dwell time for LoRaWAN where after like 400 milliseconds, you have to then switch to a different channel and then start broadcasting again. So that kind of, if you're sending something large, you got to chop it up. That's where Wi-Fi HaLow comes in. You can send data without any type of real restrictions. And then some regions do have like a duty cycle where you got to reduce your speed or you only have X amount of seconds to broadcast within like a set period of time. So yeah, this is kind of the differences between these two, but I think they're complementary in the sense that now that Wi-Fi HaLow is out there, when it comes to IoT deployments, I think it's going to be a mix of both. And for instance, here's one of the LoRaWAN sensors. Rechargeable battery can last about a year. Let's say 3 to 4 times a day. It kind of wakes up, sends over quite a bit of data. And that data in this small form factor is basically a credit card. You have an accelerometer, light sensor, temperature sensor, and GPS and Bluetooth. So all that packed into this. And then you can set it where it may sleep the whole time unless there's some sort of trigger that happens in the accelerometer. Somebody slams it or opens it. You put it on a door and somebody opens the door. That's the only time when it wakes up and it starts to transmit. So you can make it much more efficient based on how you tell it to wake up and transmit. So I can pass this around if you guys want. These run, I think, they can run about, retail is like $30, but wholesale maybe about half that price. And so you can use it for like just temperature sensing or Bluetooth, etc. So you can say like if there's it also does a survey, Bluetooth survey, and so if you know that there's like a MAC address for Bluetooth in that area, and if it doesn't, you can program it to, if it doesn't see that MAC address, then let me know. But as long as there's another Bluetooth that it sees over there, then it's still being in sleep mode. So there's some pretty cool ways to optimize this. And then there are others which are just dedicated for one type of sensing, and they can last for years. So it's just based on how much the transmit cycle is. So I'll give you an example. I went to the 7-Eleven headquarters. It's in Irving, and we had a chance to talk with the manager there. They have a corporate store that they use right there, and they still have not deployed IoT in the 7-Eleven stores. So every 2 hours, so for hot food, it's between 2 to 3 hours that they have to go in and manually measure everything in the 7-Eleven store. So you can see here, like near the bottom, it's like pizza and roller grill. They have to have a probe and things like that. And yes, it's for food safety, but some of the hot stuff, they also want to optimize, reduce food waste, because there are times where if it's just sitting too long, then they just have to do it. And right now, this process is a tedious process. Manually do all that. And so there are a lot of organizations, 7-Eleven, et cetera, that are not using LoRaWAN at all, which they could, because it could really make a difference in their way their stores are run. And a big use case is Starbucks. Starbucks, 10,000 plus locations have temperature sensing via LoraWAN, and they put them in, all the cabinets, things like that, and they broadcast every 15 minutes. So unlike usually the health department asks like every 4 hours, 6 hours, but they do it every 15 minutes, and approximately about 25 minutes are saved per store per day. So it's a pretty big 85 million minutes annually, and it's a huge savings. And I think there's going to be many more organizations that are going to start using these types of temperature sensing for food safety. And then for Wi-Fi HaLow, yes, it is Wi-Fi and it is IP based, but they have ways in which to make it much more efficient. And so their devices, you can have them where they can go into a deep sleep. And so what they'll do is they'll negotiate with the gateway or the router, and it will tell the router like, okay, I'm going to go into a sleep mode, and then they kind of negotiate that. The router knows it's going to wake up the next amount of time, and that way, when it's in sleep mode, it's on par with the LoRaWAN. Only when it wakes up and starts to broadcast, it's less energy efficient than LoRaWAN. And so this kind of is the way in which Wi-Fi HaLow is presenting themselves as kind of a competitor to LoRaWAN when it comes to like things like that tracker right there. And then if you have like 1,000 devices to one gateway, to one Wi-Fi HaLow gateway, you don't want all of them to broadcast at the same time because it's kind of overload the router in a sense. So there are ways in which they can negotiate with groups of a whole group of endpoints can then be segmented into different groups. And then again, that's all done like there's a negotiation process. And there's also flags you can set in your development where you can tell your endpoint, your sensor to negotiate, and then there's ways in which it can allow it to go to sleep, etc. The router designates all those things. So with this, it'll tell groups of devices to broadcast at a particular time. So that segments the transmission. So another way in which Wi-Fi HaLow is trying to optimize for multiple devices on one router. So let me show you. I'm going to jump out of this, and then here is the Wi-Fi HaLow camera, and this camera right here, it's coming in at about 800 by 600, and it's constantly streaming. There's no dwell time. It hasn't had to stop, etc. And this thing can be then you can capture images, things like that. And so what happens in this scenario use case is you can tell this camera to go into a deep sleep and then wake up at a particular time. Let's say a use case would be you're putting it for tracking your facility or something like that. So instead, you don't need a stream every second or image every second, but you may need one every couple of minutes or every 5 minutes. And so this way you can deploy something this small, put it out in the field, and that would be connected to a battery. So let's say you put it in a remote location, it's got a battery, and then it kind of behaves in a similar way to a temperature sensor or something like that, except now it's machine vision. So goes to sleep, wakes up, takes that image, transmits it over, and then at that, when it transmits, it can also renegotiate. And let's say you transmit the image to the server, it sees something unique about that image. It can tell that device to stay awake, and it doesn't need to go back to sleep, because when it does go back to sleep, you can't reach it. So there are ways in which to decide what's going on and make a decision on how keep the device on or off. So for instance, let's see if this works. Capture this image. We'll go over to a model. Okay, here's one from a couple of minutes ago where this is it's called YOLO V12. It's one of the machine vision models, and on the left is for the thermal camera. And then when we send it in for inference, it will actually pick up certain things. People, for instance, their signatures are pretty obvious with thermal, but thermal object detection has just recently gotten so now you have some of the newer models which are using thermal, and it's just pretty slick that we can do this. And let's see if we can upload our image that we just snapped and see if that that can be inferred. Let's see. So, here we go. So even, and this can all be done at the edge. And so with a low resolution camera like this, 300 pixel, you're able to get, even in a relatively dimly lit environment like this, you're still able to get pretty good object. And so this opens up a lot of applications where you don't need to run cabling or put a large camera somewhere. You want to deploy something. So it could also be something like, for instance, that thermal imaging. You could put that in a kitchen or somewhere like that, a commercial kitchen, and you could do a tandem, right? You could have RGB plus a thermal, and the thermal is going to detect heat signature. Somebody left the cooktop on or something like that, or other things. There could be a leakage somewhere, and it's going to know that. So you can overlay both of these together, and it pretty much allows for a lot of applications. And an image like this really could not be transmitted with LoraWAN. I mean, it would just take for, I don't know how it would be done. So now this allows for a fusion of different images, and it's called sensor fusion, basically.
What characteristics is the camera capturing of each person? Or is it only while they're static that they're able to identify them, or when they move around, does that identifier stay with it?
So see the percentage? It says like 80%, 85. That's actually percentage of how sure it is of the model. And
Yeah.
as you move, it can average out the percentages and be more certain or less certain.
Exactly. So, this is a one frame, but obviously you can do, 30 frames, 15 frames a second. And definitely as Chris was saying, like it's 85%. But if you have like even more frames like this, then it'll average out and it'll be able to track it. So it indicates, like, let's say you take an image like this, the sensor is asleep, it wakes up, takes an image like this, and then at the edge, there's some sort of analysis that gets done, there's an inference that gets done. And at that very moment, it's like, okay, we need to keep this camera on because we see something suspicious. And at that point, you can get a stream coming. So you can do a kind of a tandem. The efficient way would be to just go to sleep, take an image, and then go back again every 5 minutes, 10 minutes, etc. And then if there is something of any interest, then you just keep it on. That'll drain the battery, but that's what the point is. And so, it basically now higher data rate endpoints are now are able to be deployed with Wi-Fi HaLow. So, and
So if you try to deploy this with like an AI model, like Gemini, so what I hear is there's a lot of manual oversight or monitoring of the camera, right? Or setup or limitations or protocol that you set up with the camera. Have you tried to use a AI platform to automate that?
we haven't done that, but yes,
Technically that is an AI.
Yeah.
Right there. It's using a YOLO back-end AI model to do that.
Yeah,
Yeah,
so
I was looking at some type of images that have been labeled,
yeah, so this is just where the inference is done, the raw inference is done. So you'd have a YOLO model running on your edge or something like that. You do the inference, and then you take action based on that inference. So you can do coordinate maps, things like that, right? If there's a particular person in that area of your image or of your facility, you'd have certain logic on what to do. And so YOLO V12 is the latest model, but you can use different ones, right? There's a bunch of. Thing with YOLO is like you only look once, basically. It's real time friendly, so you can inference pretty fast with this. And there's a YOLO V12 Nano, which is a lightweight model, which then you can run on the edge. So yeah, that's one. And then, for instance, here's the dashboard of the HaLow router. So you can, right now we have this one device connected here. So, we're at, and the channel is a 12 channel and frequency over there. And you can see, the signal strength is 45, but up here, it'll tell you, you can choose higher bandwidth with less range. And then you can switch to lower bandwidth and higher range. And so, for instance, over here, you can then go in and choose. So right now we're at 8 megahertz channel width, and then you can choose obviously these 3 channels right here. But if you go down to let's say a 2 megahertz width, you have further range. But so now you have more channels. So let's just pick one and save this, and it'll take a second to reconnect. But what's going to happen is it'll renegotiate, and then the speeds are going to drop. So you're going to get less bandwidth and further range. So here we're down from 30 to 7.5 megabits, but the range is going to be. I mean, it's right here, so signal strength's not really going to change, but the range is going to be a lot. And so you're able to do all these tweaks with Wi-Fi HaLow, which just not really possible with LoraWAN. And the cool thing is that HaLow, then yes, it is. You can, if you have a particular sensor and you want to optimize it, probably there's more flexibility with Wi-Fi HaLow.
So LoraWAN, you talked about the sensors, and a lot of us are familiar with how long they can last on a battery. Is Wi-Fi HaLow comparable? Less? A lot less? What's the camera? You mentioned the cameras potentially being battery.
Yeah, exactly.
What kind of battery life are we going to get?
Yeah, so like for this whole module right here, it's a when it's at full transmission, it's using about 3-4 watts. And if you're transmitting continuously, it is. I mean, they can't even be. And in that case, LoraWAN and the efficiency issue is not even under consideration. But if you're able to do certain things, and that you're gonna have a sleep time, right? So you doze the sensor off, and then it wakes up, it connects, transmits, and goes back to sleep. That's pretty much the only way that Wi-Fi HaLow can compete with LoraWAN. That's the only way. So obviously, Wi-Fi HaLow, the range is further and things like that. So I mean, further in the sense than regular Wi-Fi. So 1 kilometer, you'd be able to put sensors like in a full building, and then have to work at making them efficient. So LoraWAN out of the box, I think you can make them. It's already by default, just by the way in which it's set up, pretty efficient. Wi-Fi HaLow, you're gonna have to work at making it. But then you have more flexibility and transmit time, things like that.
So you said this channel selection is allowed for Wi-Fi HaLow.
Yeah. Yeah.
That's, so it says allowed. Can I allow it to switch channels on its own, or I mean, anybody who's worked with a wireless protocol where you select a channel notes that
Yes.
you select a channel, it looks great, and then a week from now, that particular channel's really noisy. So it requires you to
Yeah,
monitor and to change things, whatever, so that, selecting a channel can have its disadvantages.
absolutely, absolutely. You could tell the noise here. You could programmatically do a bunch of stuff also. And you could go in and all the information is there, the noise and things like that, and you can change it accordingly.
So automatically, if the noise
Yes,
is certain threshold,
Yes.
jump.
exactly. You can change that. And that's, I guess, that's part of the negotiation process. Yeah, so this one, and then the company, Morse Micro, is, I guess they're leading most of the Halo development. And so most device manufacturers use their modules and SDKs. So if you are going to use Wi-Fi Halo, most probably you'll be using the SDK. And when it comes to machine vision on the edge, right? So for instance, that YOLO 12 that we were looking at, you can have a nano, which is a lightweight model, and then run that on the edge. And on the edge, in this case, would be not on the sensor itself, but when the sensor transmits to the router or to the hub. At that junction, you could have something like a Intel N97, relatively cheap processor. But if you're able to then run a model like YOLO or B9 or B12 on that innovative GPU, so using OpenVINO. So you put OpenVINO on there, it kind of optimizes it for the integrated graphics on the Intel processor. And then you could get maybe 15 to, I'd say about 25 to 30 frames per second on the N97. And so if you're doing edge machine vision, and you've got a couple of hundred images coming in every minute or so, you would be able to use something like Intel N97 and then make the inference right there. So instead of sending the images to the cloud, you could do much of that right there on the edge. And so this was, here it is. So this is one of the devices which are one of the manufacturers that was use N97. So, and I think the boards are, you can buy a single board of that also. Yeah,
You could buy just the board.
yeah, sub $100 for that. So, a lot of use cases. So when it comes to, somebody had mentioned AI, and so there are ways to now do inference on data coming in from your sensors. So you're able to use machine learning and AI to basically infer charts and other things. So in this case, this is the data set from that the small tracker right there, that credit card size tracker. And I set it for give me a temperature sensing measurement every minute. And so every minute, and this was put in a freezer. And I was like, what is going on right here? I was like, something's wrong with the freezer because that just doesn't make sense. That's around 23 degrees Fahrenheit. And over here, it's about minus 10 where it should be. And so, it's a recurring thing. I would see this constantly, and I was like, something's wrong with it. And I kind of had a hunch of what it could be. But then I took this image and then I put it into the Grok engine or one of these, and I guess they have a combination of vision language model and also a large language model. And so a combination of both, it came back telling me, baseline temperature 0 to 5 degrees. But it also said that spike could be either door opening or defrost cycle. And I also, before this, I prefaced it by saying, this is the model of the freezer. It's in this environment. The ambient temperature outside is so-and-so. Ambient temperature is not changing, it's 72 degrees. Gave it all that information. And then I gave it this time series chart. And then, of course, I mentioned the X and Y. And then it came back with these conclusions right here. And then it said, you know, even with, so obviously I was like, okay, there must be something wrong with the, if you see it for the first time, you're like, okay, well, maybe something wrong with the compressor because it's going up to 23 degrees. But it, or some sort of internal sensor. But that's basically how that freezer, that model is, that's how it operates. So this is pretty much how you can combine the two together and get some inference out of it. Yep.
You know, experience with the Zhao SB32 S series chip.
This one right here?
No, is that what it is?
Yeah.
Okay.
Yeah. This has an ESP32.
But there's no Zhao chip that runs a lot faster than the regular.
Oh, okay.
It's a brand new chip. Does like Wi-Fi 6.
Okay.
Yeah.
Wi-Fi 6. This one. Okay. This one is the.
Most of them were like 2.4. So.
Got it. Got it.
But the new chip from Zhao, and actually, Bowser has like a hackathon or something.
Yeah.
Chip to see. Some kind of things going on some forward with the internet. But
Okay. I'll check it out. It must be like real recent.
It's
This-
very,
Oh, very, very new. This thing is about 3 months. Been released about 3 months ago. This one with the Halo camera, but it uses that ESP. I think I'll find it out.
they do have
Probably an
chips
S3.
on
That's
Amazon.
pretty. Yeah.
They're fairly cheap. Chip.
Yeah.
I was actually going to buy a couple of them.
Yeah.
It has an external antenna you can attach onto it, which is pretty cool. And
Here's the antenna for this one. I just stuck it on the side here.
it does
But-
NB and all these other protocols.
Exactly. Yeah, it's pretty. It's amazing. It supposedly does some inference on the. I mean, I couldn't get it to
it's
work.
a tiny image. It's not as good as what it is.
I don't know what it would work. I see something. This one, yeah. I mean, and the prices are just so like for the Halo module. I think it's around $5 or $6, and then the camera and everything. Retail was I think something like $35 for this thing, but that's like one unit.
Anything with like WRT with it?
So that
That's supported as well.
yeah, exactly. So the dashboard for the router, that's based on Open WRT. So they use WRT, and then you can go in and change it around if you want to also. Yeah, it's sitting right next to you over there. It's a small one. Yeah, so yeah, I mean, Morse Micro SDK, and then they have it where they have their own image with integrated with Open WRT. Yeah. So yeah, please.
You said you're using the YOLO VA model, right? So you either nano, have you tried it with the small or is it small beyond
Oh, for the edge for that thing, right? It will work on actually the small will work also.
so which means your machines has the capability to
Yeah,
handle the small ones.
correct. You can do small. I think it's about this. I'd be a little conservative on this one, but the small you can run it on a N97, but with OpenVINO, and then it's optimized for the integrated GPU, and then you can run a small.
You change the model size of the VA at all, or the nano at all?
We did a few more annotations that added some more things to it, but it's just a little bit.
So I'm just curious. Model parameters or is it the same?
It's the same.
It's the same.
Could be. We're going to do the newer yellow model too.
Yeah. So the newer one has it's the thermal stuff is just incredible, which it's gotten a lot better from previous, and so that also allows for like sensor fusion. So yeah, about my startup. So if only all of this was kind of bundled up together. Hence, this is one of our form factors right here. It is I'll show you. We have basically everything integrated. So this is a prototype, but within this form factor, we have a 5G advanced module. We also have a Quintel BG77, which is a Cat-M and NB-IoT ready module also in there. So we have two modules in there. And then there are antennas also in there, the 5G 4x4 antenna, and then the LoraWAN and Wi-Fi HaLow antennas. So this one is pretty much a smaller size for the Wi-Fi HaLow, or 900 megahertz. But you can get it if you have it a little bit larger, you'll get.
Like plus 10 dBu or higher in that in big count.
I think it's like about 4.
Okay.
Yeah. But
It's big enough. But
yeah.
Like,
So we're not using the whole tower.
Okay.
A chunk of it is where all the components are, and then the rest is basic. And why this form factor? It's because we're in this we want it to be like a quick deployment where you just plug this thing in and it's good to go. In the sense that you're able to deploy multiple units of this in your facility, and then have IoT coverage and Wi-Fi coverage. And basically, obviously 8 foot tall. It has so that N97 that you see, that board, something like that will be in this tower. So it'll have edge computing on the tower. It's going to be lightweight, but it'll be there to do some inference. So you have a couple hundred endpoints. This thing can handle a lot of it, especially some of the machine vision. So we're able to put all that in there. And so with IoT, it has Wi-Fi HaLow and LoraWAN. So as we discussed, it'll handle both, and then put all that into a dashboard. And when it comes to enterprise 5G, so each tower is connected to the internet independently. But we have something called a zero trust network, which basically combines all of them together. So what happens is if you're connected to one tower, and you want to reach another tower, it's all in a virtualized network. So everything is reachable within your network. So that other tower could be 50 feet away or 500 miles away. It'll still be. It's zero trust. It's not really VPN. It's zero trust protocol. Yeah. No, it's a proprietary. Yeah. So the zero trust allows us to then, we can go through T-Mobile, etc. We'll have our own. We can have a router in the cloud also to designate, like have the routing tables, things like that. So if you want to set up your own tables, we can do that. We have a DNS server, also all that on the cloud, and all this becomes virtualized. So if you have one tower, let's say 100 feet away or 50 feet away from another, and you're connected, it will do Wi-Fi roaming also. So you can have your phone connected to one, and it will do a fast transition to the next tower. So let's say you have a facility and you put 5 or 6 of these in your facility. Each one is independent. So another question we get is, well, it's 5G. How are you going to, the bandwidth is still kind of low. And we're saying that each one of the towers has its own dedicated band. And so now with 5G advanced, you're getting faster upload speeds, over 100 megabits. So 5G advanced plus this allows us to now, so you may get up to 1 gigabit download and 100 megabits upload 5G right now. And so if you were to put these, strategically within your facility, you could pretty much have connectivity, Wi-Fi, internet connectivity also. So these towers are for both for IoT and for enterprise. So yeah, that's kind of how we are positioning ourselves. Working with a couple of ODMs on all the components, and that's basically in the top 3 feet right here will be all the components, and this is basically channel. And on the top, there's a power over Ethernet port. So a few of our customers got feedback and they're like, we want to still run a cable to the ceiling to run our cameras or et cetera or something else. And so in that case, we just do that. There's one port in the back also. And this way you can deploy this quickly and not worry about any cables getting in the way. Things like that. So yeah, this is, and then we're working with having the base and the form and all the housing made locally. Yeah, Vik Mehta, you can contact me at Vik. And all that.
Is the, LoRa on there, is that, mesh tested?
No, it's straight up LoRa. Yeah.
This kind of thing's not quite ready for enterprise. It's still obvious.
Well, not as far as the chipset.
It's the same chip,
Well, they have different, there's actually
different software.
the Caltech makes them
It's
a
actually
LoRa chip that is not mesh tested compatible, and then there's one that's.
Oh, that's the older. That's the older synthetic.
Yeah, so the newer chip, as I was asking, if it's the newer chip that is.
No, and the reason is, yeah, the manufacturers, right, that are making the sensors, things like that, they're all sticking with for now. And I think that's going to be a long-term thing for that. So, and how we are approaching this is you can deploy a tower, you know, to start with one tower and then see if that is enough to cover your facility. And that would have Wi-Fi HaLow and LoraWAN on it. And then we're trying to work with some of the sensor manufacturers to make it a much easier provisioning process, especially for LoraWAN. So there may be ways in which you could just, you know, scan your phone, provision, use your camera, scan the sensor, or use NFC, and then it gets provisioned to that tower. So a couple of ways in which we're trying to do that. So, and I know Mishtastic is pretty cool too, right? You can do, you can basically build your own operator. You become a mobile operator with Mishtastic.
There's actually quite a large network over there in Plano, Richardson.
Yeah.
This area. Operators like.
Yeah.
For messaging stuff like that.
They just formed an alliance just an app to start removing to business enterprise use. So it's been primarily hobbyist driven, but it actually is the same syntax in a lot of cases.
Chris, can you just summarize what mesh testing is?
So it's a hobbyist variant of LoraWAN. It's the closest thing. What it is it uses the same exact chipsets and frequency range, but it creates a point-to-point, or actually it creates a mesh network that allows you to send point-to-point primary use cases text messages. So you think if you don't want to use your carrier and you want to send super secret messages to your friend, you can use the common use case is you use an app on your phone, turn off all the radio except the Bluetooth, connect to Bluetooth to the Meshtastic device, and send secret messages to your pals. And it's very secure because it's encrypted point-to-point, where you can send broadcasts. But one of the options is when you build a Meshtastic device and gateway, you have the option to share it with the world. So if you go to meshmap.com right now, you'll see what you were suggesting. You'll see what the RF coverage looks like, and it's all obvious. In the UK and Western Europe, they have complete coverage. But the whole of the UK islands are 100% covered. So you can use an off-grid, untraceable text message.
There's two options. You can create your own channels.
Yes, you can. You can create
a company channel, you know, kind of thing versus
yes.
Communication.
You can create
Or you can use the
yeah.
Open unlock channel for like broadcasting with all the people that the newbies that get on there and they want to test their system. They send paintings and stuff.
It's about $50 to start. Buy 2 little devices to start playing.
You actually set up some of the BBS with it too. They'll have an AI BBS set up with it. So you send a message. It uses WiFi to basically answer or give you the weather or different types of stuff. They'll text you back.
Yeah, it's pretty cool.
Yeah, it's I mean, I've heard people are trying to bypass the operators, right? allow operators can come up with that thing. You guys use helium?
Yeah.
Yeah, I tried helium like in Frisco, and it showed that there's one like across the street from me, and then the one I connected to was like 2 miles away.
One problem is like, millions of those networks. I had a couple of million of those.
Yeah.
And, network profit type thing. Whereas, as far as bouncing your signal off of them, should all be, open, and I think that's where the best traffic comes. All the other, the meshing of all these different operators, the more and more people are buying those and stuff.
It's $60 on Amazon. You're ready to go.
Yeah,
It's
yeah.
great.
And then you link it up with your phone. And actually, they just came out with a little pack. And it's a magnet. It connects on the back of your phone, and it charges your phone at the same time. And it has a Mestastic killer.
Yeah. Is it Mestastic also on the same
I think-
license?
Yeah, you can, it's on the same frequency.
Okay,
It's
yeah.
in that unlicensed 915.
I guess it's getting
It's sort of
it's
like
getting
you're
crowded.
able to bounce off all these other nodes that are already out there. A lot of it, big push on a lot of them.
Go to meshmap.com and you'll be surprised. It's pretty cool.
Okay.
I think it's meshmap.com. Yeah,
It looks like it's a separate layer or something.
But it's the same chipset that you're using. Yeah, meshmap, there it is.
You can do private messages.
Yeah, look at that. Zoom into like the UK. See, it's just nuts. Look at all the, compared to cell towers, that's insane.
Yeah.
Right?
Yeah, I tried helium, and I get it. I mean, the open network, but if you're using LoraWAN for enterprise,
You want a little soft.
yes, you want something reliable, because any one of those could turn off. Yeah, somebody unplugs it or
It runs out of battery.
runs out of battery. Didn't pay the
It's
internet
also
bill.
not as energy efficient. Meshmap's nowhere near as energy.
And then you can
It's good.
MQTT on the back end to set up channels long distance to the private network.
That's what they're. I think that may be the use case, right? Is for messaging.
Oh, there's new use cases. That's why there's new alliances formed. Because they are looking to move it into enterprise business. Because right now it's hobbyist driven. That doesn't usually mesh well with
Yeah. But yeah, thanks for coming and